Hi students, see you again. So this one is a discussion for the SPM Form 4 SSM. I will discuss all the exercise about chapter 1 until chapter 6. Okay, please refer the question and also check your answer. Okay, this was the first question. There's okay, I show about the pen first. Okay, diagram 1 below they show about the structure of the thermometer. Okay, now what's the temperature shown by the thermometer? So we need to check. Okay, let's go to zoom first. Okay, you can see this one is a 36, is it? So 36, after that this one should be 37. Okay, so we find it inside got 10 division. So this one should be 36.1 degrees Celsius. Okay, so we check the answer. So the answer is 36.1 degrees Celsius. Remember to write your unit. Okay, now we go to B. State two factors that can increase the sensitivity of the mercury thermometer. So for increase the sensitive thermometer, so we got two things. One, you must say about the bulb. Okay, you're using the thin wall bulb. Number two, you must say about the capillary tube. Okay, the center, that one we call capillary tube. You're using the narrow capillary tube. Okay, so you can see the answer. Okay, thin bulb of the wall, smaller capillary tube. Okay, so this one should be the answer. Okay, then we continue explain why the empty space in the capillary tube should be the vacuum. So we want to put vacuum inside the space here. Why? Okay, if vacuum, that means we don't have any air molecule, we don't have any pressure. So if you don't have any pressure, that means they do not affect the mercury coulomb. They do not move up and move down. So that's why I want to fix the mercury coulomb, the location. I don't want to let it to move. So that's why I need to mention, so that there is no pressure inside to allow the mercury in the coulomb can be moved freely. That means they fix the location of the mercury. Okay, then we go to D. Position of the observer eyes must be the best to make the accurate reading. So this one I think everybody also know, because we want to prevent the parallax error. So the answer here should be B. Okay. Okay, now we go to question 2. Question 2, they show about the experiment carried out by the student to measure the diameter of the wire. Okay, diameter of a wire, that means I want to measure one wire only by using ruler. Okay, give one reason why the student they uses 30 turns of the wire to measure the diameter. Why we never measure one wire only? Why we need to wound by 30 turns? After that, go to measure, then they go to divide. Okay, important is your ruler cannot measure one of the wire only. Okay, one of the thickness wire we cannot measure. That means you cannot get the accurate answer. So from here, that's why they want to measure 30 turns of the wire. Later we find the mean value. Okay, so from here the answer is single wire diameter is too small. Okay, to be accurate measure. So too small already, you cannot get the accurate answer. Okay, B, explain why the wire need to wound 30 together during taking the measurement of the 30 turns. Okay, they want to wind tightly. Why they want to wound tightly? First one, you want to wound tightly means you want to reduce the space lah. You want to reduce the space between of the diameter, then we can measure by using the ruler. Okay, number 2 is we measure by 30 turns. The reason is we want to make the answer more accurate. Okay, because you find the mean value, your answer is more accurate compared you measure one of the wire only. So from here we give the answer. Okay, by measuring 30 turns of the wire diameter together, so you find it the error will be reduced. Okay, you reduce the error. Okay, because you measure one of the wire, they got more error compared to 30. Okay, next one. You ensure there is no space between to each coin. Okay, now we go to C. Okay, C, they show what's the diameter of the wire. Okay, what's the diameter of the wire? So that means you need to take the measurement just now. After that, you need to divide by 30. Okay, so we show the Calculation. Okay, that one they show 5.8. Then you need to minus the earlier, they start 4.5. So I find it 30 turns is take 1.3 cm. So if I want to find 1 turns only, so your answer should be, okay, 1.3 over 30. So 1 turn is only 0.043 cm. Okay, 0.0043 cm. Okay, now you need to suggest one more suitable instrument to measure the diameter of the wire. So diameter of the wire is too small. So that's why we need to using the another instrument to measure the thickness of the wire. So from here, we cannot using ruler. So you can using micrometer screw gauge. That one it can measure until 2 decimal point in millimeter. So that one is suitable for measure the thickness of the wire. Okay, now we go to the question 3. Okay, they show about the ticker tape obtained from the trolley moving from the runway. Okay, every tape they got 10 ticks. Okay, then the frequency is 50 Hertz. So you can find here, the tape is keep drop. Okay, keep dropping means they slow down already. So can you describe the motion? So the motion, I know there's a velocity decreases. You also can say deceleration. Okay, if you make sure there's a constant, so you can add uniform deceleration. So every answer we also accepted. So from here the answer, uniform deceleration. Velocity decreases also can. Deceleration only also can. Okay, describe the power. Okay, for the ticker tape and ticker timer, we're using the power should be alternating current because you need to vibrate. Vibrate means they're repeated. So we're using the alternating current power supply. Okay, what's the time interval for 10 ticks? Okay, 1 ticks, just now they say 50 Hertz. So I know 1 tick is a 0.02 second. Now I got 10 ticks. So you just multiply. So the answer is a 0.2 second for 1 bar. Okay, 1 bar. So now first one, they want to find initial velocity. So initial velocity means the first bar. So the first bar, how many cm? 25 cm. So the time taken is 0.2 seconds. So we do the calculation. 25 over 0.5. So there's a 1.25 ms negative 1. Okay. Okay, another one should be find the final velocity for the last bar. The last bar is a 15 cm. So the formula is the same. 15 cm over 0.2. So I get it 0.75 ms negative 1. Okay, last, you need to find the acceleration. Remember, for the acceleration, you need to find the time interval. Time interval means you need to jump. From the first one, jump 1, 2, 3, 4, 5. So that means you can take total here, got 6 bar, you go to minus 1. Okay, minus 1 of the bar, then multiply with the time. So I show you the formula. A equal V minus U over T. So the V I get is 0.75. Then the U just now is 1.25. So this one is a time interval. 6 minus 1. Then multiply 1 bar is 0.2 seconds. So finally I get my answer is a negative. So negative means correct lah, because I want to get the answer is a deceleration. If the question asks deceleration, that means I no need to put the negative. Okay, acceleration means you need to put the negative. Okay, question number 4. This one is a diagram that shows the man of the 60 kilograms that jump from a certain height towards the floor, which has a thin mattress. Okay, now we got B. Diagram B, they show about the same man also jump, same height towards the floor, but now they got using the thick mattress. Okay, now they give you the gravitational acceleration, there's a tap. Okay, now you describe the motion of the man when they jump in the floor. Okay, so when they just jump, we can call it there's a free fall, because you never go to up and go down, you just go down only. So this one free fall because you got gravitational force to pull you to go down. So that one we call it gravitational acceleration. This one G. So the motion, how? The motion must be fall down with gravitational acceleration. That's how many? 10 ms negative 2. Okay, that one is the motion when you just fall. So from here, they fall with the gravitational acceleration of 10 ms negative 2. Okay, if the height is 8 meter, so we just take this one, height is 8 meter. Calculate the velocity of the man just before he land on the mattress. So that means when it just start to fall, U equals 0. Remember, U equals 0. A must be 10. Okay, then the displacement, we know there's a 8 meter. You need to find the final velocity. So that means the whole question never mentioned about the time. So we're using fourth equation. Remember the fourth equation, so I show here. V square equal U square plus 2AS. But this one is a free fall, so we take this as a G. So V square we do know, U must be 0 already. 2, then 10. Then the height is a 8. So I find it, the velocity, you need to square root. Then the answer is a 12.65 when they just reach to the ground. Okay, then we continue to impulsive force. Okay, if he stopped within 0.2 seconds, okay, on the thin mattress, okay, 0.2 seconds. So you want to find the impulsive force. That means you need to take changes of the momentum over the time taken. So we find it, F equals 60, that's a mass. Okay, initial, 12.65. The final should be 0 because you stop. Okay, then the over 0.2. So from here, we just ignore the negative. The reason is because that is a impulsive force. We're just talking about the force acting to the person. Negative, that's not related. For this one situation, they're not opposite direction because this one is a slowdown. Okay, so from here, I get the answer is 3,795 Newton acting to the person when it's just landing in 0.2 seconds. Okay, now we compare another question. Another question is they stop in 1 second. Okay, that means the time become longer already. So we find it 1 second means the thick mattress. Okay, so 60 is the same. Then after that, there's a 0 minus 12.65 over 1. Okay, then after that, we find the answer is a 759 Newton. Okay, so we can find it when the time just longer. Okay, then you get it, the force will become smaller. Okay, this one is a relationship between the impulsive force and also the time taken. Okay, then we go to the next part. Okay, the next part is a D. Based on diagram 2A and B, identify which one situation will likely cause the leg injured. Okay, so from here we find it sure it's a thin mattress. Because thin mattress, you take the time become shorter. So we just choose, the answer is A lah, diagram A. Okay, now if no mattress is provided, what should be done for the man when landing avoid serious injury? If no mattress, what they need to do? No mattress means they need to bend the knee. When they just bend the knee, you will find it, they'll make the time become longer. Okay? So from here we get the answer. Bending the leg when just landing to extend the time. Okay, now we go to the question 5. That one is a chapter 3, gravitational. Okay, then diagram 1A, they show about the object with the mass located the surface of the earth. Okay, diagram 1B, they show about the object moving in orbit, the height, there's a h. So that means they got extra one of the h. Okay, above the earth's surface. Now the mass of the earth is a m and the radius of the earth is a r. So this one is exactly the surface for the earth. Then this one is the object that orbit the earth. That means the height above the earth is a h. Okay, so the r is the radius of the earth. Okay, now this one sentence, you need to complete the sentence. Okay, Newton law of gravitational state. Okay, that means they want to mention about the formula. Okay, they state about the another body with the force which is what to produce to product the masses of what. So from here we get it. There's a which is directly proportional to the product of the masses. Okay, that means the force is directly proportional with the mass and also inversely proportional to the square of the distance between their centers. Okay, so one is directly, another one should be inversely. So we showed about the formula because here they want to explain the statement in formula form. So that means this one is the force. Then directly proportional with the mass. After that, inversely proportional with the square of the distance between their center. Okay, so this one is a gravitational force, the formula. Okay, now we go to answer. On the Earth's surface, the strength of the gravitational field. Okay, they're giving this one unit. Okay, write the expression indicating the force of the gravity. That means we're using the force, but now they want in gravity. So what's the relationship for the F and also gravity? So the answer should be F equal, normally we say ma, is it? Because now it's a gravity. So F equal mg. Okay, then the next you need to show the relationship between the force and also the constant universal gravity. G, that's this one. So you need to prove. This formula is how to come. Okay, by related the force and also the gravity. Okay, so we can combine two of the equation just now we learned. Okay, we just write F equal this part. Okay, this one is original. Before that, we say about directly proportional and inversely proportional. Then after that, F also equal to the mg when we're just talking about gravity. So now, actually, the small m we can cut. Okay, the small m is a mass. Okay, so from here, when it just cut already, so we just find it. G will equal to the capital G, then multiply with the mass of the Earth. After that, the distance. Okay, so this one is the formula how to prove it if we're using the two equations. Okay, now we go and see the question. Refer the diagram 2B. Okay, actually it's a 1B. I think the problem of the question. That's a 1B. Show how the expression of the acceleration G equal this one formula. Okay, we need to measure how, not measure, we want to prove. Okay, we get this equation. So just now it's a R, is it? So this one got one more H. So you can refer the diagram here. You can refer the diagram here. So from here we get the radius. Then remember the object is moved out of the Earth. So you find it got one more H. So from here we need to prove. So we mention first. Since the satellite's distance from the center of the Earth, there's a R plus H. So we can write the equation now. Okay, this one equation we proved already just now. So you can write G equal capital G M over R square. So from here the R, because of this part, okay, the object is moved further from the Earth. So we need to plus one more distance. Okay, that's a H. Then after that, remember square. Okay, then the next one is the object is orbit the Earth at the altitude 1000 kilometers. So that means now the object is orbit outside the Earth. Okay, the H, just like just now the diagram, there's a H. Okay, what's the gravitational acceleration value for the satellite? Okay, they want to find the G. So from here, they give you the information. Capital G they provided, then the mass of the Earth and also the radius of the Earth. So from here, we need to find the G. So the equation like this. Okay, so from here the G is okay, no problem. We just put in the answer here. Okay, the mass also no problem. Mass we just from the question we just copy. Okay, now the bottom one. Divide, because the object is not exactly at the surface. There's a out of the surface. Okay, how many? 1000 kilometers. So we need to plus. Okay, this one is a radius. Plus 1 times 10 power of the 6, because this one is 1000, then kilometer is 1000 again, so becomes 6, then square. Okay, final answer for the gravitational acceleration, there's a 7.33 ms negative 2. Okay, then we continue with the question. The following table they show about the radius of the orbit and also duration of the planet around the sun. Okay, complete the table, okay, with the t square. Okay, t square means the periods over the r cube. R cube is a radius. Okay, you have me to change from your question. Your question just write kilometer. I want to change become meter. Okay, another one is a million. Million, you must know they got 6 0 behind. That means you can say the same like the mega. Okay, now we need to find out this answer by using this formula. So t square, you need to take this one. Okay, go to square. Okay, this one is a days. Remember the unit they show about second. So days, how the chain becomes second? There's a multiply 3600. Okay, but now 1 days, that one is 1 hour. 1 day got 24 hours. So you must take 24 hour multiply 3600. That one just got 1 day. Now I got 225 days. So I show you the answer first because we got big numbers. Okay, the days 225 multiply 1 day, 24 hours, then 60 minutes. Then you need to convert to the second. So you multiply 60 and 60. Remember, go to square. Okay, this one is a radius. So if I convert to meter already, so radius million got 60. So 108. Then after that we got 60. Then remember, go to cube. Okay, follow the formula. So final answer, I get 3 times 10 power of negative 10. Okay, the unit already provided, so you no need to write. So I show all the answer here. Okay, this one is the second one for the Jupiter. Okay, for the Earth, this one is 3 times 10 power of negative 10. So now you can compare. Actually the answer we get it, they're almost the same. Okay, if you're using the Kepler third law, this one is a Kepler third law formula. So we find the answer is almost the same. If you find it, the time and also the radius different, but when you do the calculation, they get the answer is almost the same one. Okay, so from here we can prove the Kepler third law. They're just talking this formula for every planet that should be equal. Okay, so we continue. Okay, so what do you observe about the t square over r cube value for all the planets? We find it almost the same. So the value is almost the same. So they follow the Kepler law that verify the value of the t square and r cube. So from here we can prove lah. We can do the calculation already. So we need to state the Kepler law. Is it they verified this value or not? So from here we find it. The Kepler third law, we state that the square of the period, this one square of the period of the planet around the sun is directly proportional to the cube of the radius of its orbits. So that means when your radius just bigger, you find it the time taken must be longer. So this one is a Kepler third law. That means T and R, there's a directly proportional. Okay, then we continue the diagram that show about the satellite A. Okay, satellite A is here. Then the satellite B is further. Okay, T1. Okay, the orbit for the Earth with the period T1 36 hours for the satellite A. Then the Earth distance to the satellite A, okay, 5 times 10 power of 7. And the radius of the Earth is 6.37. So that means the question never mentioned B. They just mentioned A only. So this one is radius. Okay. Then after that they say the Earth distance satellite A. Okay. Another one. This part is the 5. So if you want to find the satellite distance, you need to plus. Okay. Distance between Earth and satellite and plus radius. Okay, then we continue. Okay, now find the value of the ratio t square over r cube for the satellite A. Okay, we go and refer back. Okay, satellite A, they give you the time 36 hours. So hours you need to convert become second. Then the radius. Okay, radius, that means you need to plus 2. Earth and also distance. So we need to show. Okay, distance for the satellite A to the Earth center, there should be plus. Okay, after plus, I get this one answer. Then I can apply my formula. Okay, this one is a t square. That means you take the time taken, you go to convert, becomes second. Okay, so after that I divide by the r cube. So I get the answer is 9.38 times 10 power of negative 14. Okay, second square per meter cube. Then if the Earth distance for the satellite B, okay, now they're talking about satellite B. Okay, satellite B, they give you the distance. Okay, power of 7. Okay, find the orbital periods of the Earth for the satellite B. Okay, now the question they reverse. They want to find T, but they give you the distance. Okay, so from here we need to know Kepler third law. Kepler third law, just now they show you formula, T square over R cube. They say there's a same. For every planet, there's a same. Okay, maybe your time taken different, then your radius also different. Final answer you get when you do the calculation by using Kepler third law, the answer is almost the same. So from here we can say the satellite A and also satellite B, by using the Kepler third law, the answer should be the equal. So we just take the answer from here. Okay, for both the satellite orbiting the Earth, the value t square over r cube is the same. Okay, this one is a Kepler third law. So we can take the answer from there. Okay, just now we find already. So we get the distance first. Now it's a satellite B distance. Okay, this one is a radius of the Earth plus the distance of the satellite. So I get this one R. Okay, now formula t square equal 9.38 times 10 power negative 14. Then multiply with the 6.637 times 10 power 7. Then you need to cube. Okay, so the final answer, I get it, 2.27 times 10 power of 10. That one is not yet square root. So you need to go to square root. Okay, after go to square root, I get 1.66 times 10 power 5 seconds. Okay, this one 9.38 actually is from here. Okay, so I just want to find the t. So I take the radius, multiply with this answer. Okay, then we go to question 7. Question 7 is talking about the heat. Okay, now you see the diagram. They say the flow of the heat energy between two objects. Okay, A and B. Then another one also same. Okay, but you can find about the arrow. The arrow from the first diagram, they got more from the A to B. Okay, more means what? More heat to transfer. Okay, so explain the meaning for thermal equilibrium. Thermal equilibrium, when you just mentioned, they got 2 points. Okay, one is what? Net heat flow equals 0. Another one is both objects become same temperature. That one is a thermal equilibrium. Okay, thermal equilibrium occur when there's a no net heat flow between two objects and also both objects in same temperature. So that one we call thermal equilibrium. Okay, then you need to using the diagram A and also B. Compare about the flow of the heat energy. Compare which one is flow energy is more. And also the temperature. Then you need to explain the relationship between the flow of the heat and also the temperature. Okay, from the first diagram, we find it that A is more heat energy transfer to the B. Okay, then understood the A temperature should be higher lah. Okay, from the second diagram, I find it both become almost the same. The temperature becomes same. Then the heat flow also same, but the net heat is a 0. Okay, so relationship for the flow heat and also temperature. Temperature high, the flow heat must be high. Okay, so 5 marks. So at least you got 5 points. Okay, let's see how to get the 5 points. Okay, heat energy flow in both directions. So the first part you say, heat energy, they flow by two objects. Okay, A and B, they also flow. Okay, then after that, the net flow of the heat energy in diagram 1B, there's a 0. Okay, when starting A, B also got flow. When at the B, net flow heat equals 0. The heat energy flow at a faster rate from high temperature objects. Okay, there's a from object A to the low temperature object B in the diagram 1. So diagram 1 only. Diagram B, no. Diagram B already is a 0. So you must mention heat energy they transfer faster where? From high temperature object, there's a A, to the low temperature object B. Okay, number 4, you're talking about the temperature of the object A and B in the picture 1. That means the diagram 1A, there's a difference. So you can say about the A is higher temperature lah. You can say different, you can say A is more temperature. Okay, so the temperature of the object A and also B in the figure B, that's the same. So you mention for the diagram, different temperature. Okay, B1, they say about the hot water, they storage the tank, 20 kilogram of the water, given the specific heat capacity. Okay, now how much heat is needed to raise the water in the storage by 1 degree Celsius? Okay, they want to find the energy, heat energy. So heat energy, the formula is a Q equal MC square, Q equal MC data. Okay, Q equal MC data. So you need to find the Q. Okay, now the Q is equal M, 20 gram, 20 kilograms. Okay, C is 4,200, then increase 1 degree Celsius. So I get it, 20 multiply 4,200 multiply 1, for the answer is 84,000 joule. Okay, now the power heater provided 2 kilowatt. Okay, switch on for 20 minutes. Then calculate the average rise in the temperature. When the question is using power, that means we need to using another formula. There should be PT. Okay, PT equal MC data. Q is a heat energy. PT also is another way to find the heat energy. So PT equal MC data. Then P is 2 kilowatt. So we multiply by power of 3. Time taken is a minute. So convert to second. So the mass is 2. Okay, 2. Mass is how many? Okay, from here the mass. Okay, the question here. 20 kilograms. Then this one is a 4,200. That's a specific capacity. So the data we don't know. When I just changes from the power, we need to find the temperature. So we get the temperature rises is 28.6 degrees Celsius. Okay, now the pressure cooker, they can cook much faster. Explain why. First one, the pressure cooker must be closed all the way. The pressure inside the pot must be high. Okay, when the high pressure, that means the temperature to heat the food also increase because they never release. So that means the pressure high, temperature also keep increasing just inside the pot. Finally, your food can be heat up faster. Okay, so from here, high pressure is trapped inside the pressure cooker. This causes the boiling temperature of the water increases because you do not lose the energy. Last one, the cooking ingredients will be cooked faster at a high temperature. Okay, so here is one of the example. Okay, question 8. Okay, they say the body, the base, and the handle to make the difference of the material. So the list are the different material and their specific heat capacity. So we got 3 parts. We got handle, we got body, and also the base. So later you need to list out is a material we need to use, the specific capacity, and also the density. Okay, now we go through the question. Okay, so from here they want you to find out based on the diagram to fill in the table below with the high and also low specific heat capacity. So for the handle normally you want to heat up faster, is it? So the specific capacity must be high. Okay, then density must be low lah because you want to hold, is it? So the answer is low. Okay, how about the body? Body I want to faster to heat up, then the density specific must be low. Then the density also must be low because you want to hold the body of the pot. Okay, last one is the base. The base also want to heat up faster. They want low specific capacity, but the density for the base must be high because you want stable. Okay, the pot to be moved here and moved there. So I want stability, so I want high. Okay, now which one material suitable to be used for the following part of the cooking pan? Give the reason. So the body, so we choose from the just now table. The body we mentioned already, I want the low specific capacity. So from there, we go to choose the diagram from the table just now. So we choose the aluminium body because can hot faster, get hot faster. Because aluminium body in the just now the diagram, they show about the specific capacity should be the low. So we go to get aluminium, then we give the reason. Okay, then the base, we also refer the table. Okay, the base I want low specific capacity, so from here they find it there's a copper. Okay, copper base. Reason on the heating is very fast. So although just now they say about the aluminium is a get faster hot, is it? We also know there's a meaning should be the same. Don't using the same word to explain. So from this one we just say heating is very fast. Okay, how about a handle? Handle must be high specific capacity because you want to hot faster, is it? So from here we're going to choose there's a plastic from the table, plastic holder. The reason is there will be not get too hot when the heat is absorbed. Okay, that means they heat up slowly. So other than the specific capacity, can you give the two other factors that's important when you choose the material above? Okay, so from here, we need to choose, beside for the specific capacity, we need to check about the melting point. Okay, the melting point must be high. Okay, because it's not easy to be melt. Okay, another one must be the conductivity of the heat. You want to conduct heat faster. So this one is a two factor when you want to choose the material for cooking. Okay, then we go to question 9. There's a wave. Okay, now they show about the pendulum X. They got 5 polystyrene of the pendulum with the different length. Okay, fastened to the thread. Now which one pendulum can be oscillate with the maximum amplitude? Okay, they oscillate the pendulum X with the period 2 seconds. The others one they start to oscillate also. But they just want to find which one pendulum can be oscillate to the maximum amplitude. Okay, that means from here we need to find out that almost the length is the same. So from here I choose S, pendulum X. So they ask about reason. Why you choose that? Because they have the same natural frequency. Okay, you can say about the length is the same, but it's important you need to mention the frequency. Okay, so S is forced to oscillate as its natural frequency. Name the phenomena, though this one phenomena should be the resonance. Okay, calculate the frequency of the oscillation of the pendulum. Okay, just now they give you the periods already, is it? So we just do the calculation. Okay, t equal 2 seconds. You want to find frequency 1 over t. So I get it 0.5 Hertz. Okay, now pendulum X will stop to oscillate after a few minutes. So from here you need to sketch. Okay, displacement time graph, sketch the damping diagram. Okay, so we go to show. Okay, so this one is the diagram. The amplitude they just drop. Okay, so we find it the period also no. Okay, so from here we just do the correction. Because when you just damping, you find it the time taken. The time taken becomes smaller and smaller, is it? If displacement, yes, displacement, there should be the constant, the wavelength. But this one's no, we're just talking about the mass. So you find it the time taken becomes shorter. Okay, when they just slowly to complete one oscillation, the mass taken must be slowed down. Okay, they must fast. From the A to B, come back to the A. When it just damping, you find it the time taken there will be different. Okay. Okay, now they got wave, sound wave. Okay, this one is an interference. So we're going to compare what we highlight. Okay, A is a distance between the speaker. Okay, D. So the diagram 2.2, the D is longer. The A is a constant. Okay, how about the X? Okay, the X for the first diagram, the X is smaller. Okay, another one should be the bigger. Okay, now we're going to check the question. Okay, first one, they want you to compare the x between the consecutive louder sound in two situations. So the x must be the 2.2 is longer than 2.1. Okay, so we just answer distance x between the two consecutive louder sound in the diagram 2.2 is larger. Okay, if the question got mentioned x, that means you can use the x lah. If the question never mentioned the x, you need to write the full words. Okay, number 2, you need to compare the distance d, okay, between the two loudspeaker to the x. So the d also 2.2 is longer. So the distance d between the loudspeaker to the x is 2.2 is larger. Okay, relationship d and also the x. So we find it when the d longer, the x will become longer also. So should be directly proportional. So the distance x decreases when the distance d decreases. Okay, now state one other physical quantity that need to be fixed to make sure the relationship just now I mentioned. So from here, what should be constant? The A must be constant. Okay, this one is a constant variable. So the distance between the two loudspeaker. So from here, name the phenomena. So this one phenomena is a interference. Okay, now we go to the frequency of the audio signal generator is decreases. We make the F drop. When the F just drop, means the lambda will be increases. Okay, because V equal F lambda. So from here, we answer the question, what's the meaning for frequency? Frequency means time taken, they give you 1 second. Then they need to know you do how many complete oscillation. So that means they just number of complete oscillation in 1 second. That one is called frequency. Okay, number of complete oscillation per unit of time. So what happened to the distance between two consecutive louder sound? That means they ask about the x when the frequency decreases. So frequency drop, then wavelength increase. Wavelength increase, x also increase. That one is directly proportional. So we just write distance between two consecutive louder sound will be increases. Reason. So the reason is when frequency decreases, wavelength increase. Wavelength increase means the x also increase. So remember your formula for the interference. There's a lambda equal ax over d. Okay, after that we got 11. There's a light. Okay, this one is a optical fiber. So in the diagram, show the beam light entering the inner core, one end of the fiber optic. You need to draw the ray. So this one, they're using the phenomena total internal refraction. So just show the diagram. The ray will be refracted in the tube. Okay, so this one should be the answer. The angle, make sure there's an equal. Okay, state the phenomena. So the phenomena is total internal refraction. Okay, now they show you two of the glass prism can be arranged to form the optical instrument. Okay, now you need to place the prism in the optical instrument, become the periscope. Okay, so this one is a prism, so the light must be go in. Okay, the light go in, that means you just put the triangle shape. First part should be the normal, exactly the 90 degrees, let the light to go in. So from here should be arranged like this. Okay, one put at the top, another one put at the bottom. Okay, so make sure you know how to rotate the triangle. Okay, name the optical instrument above. So this one optical, we call it as a periscope. So now if the critical angle of the glass prism is 42, can you draw the ray diagram? So 42 means there's less than the incident angle. So that means the incident angle for this one arrangement must be 45. 45 already more than 42 means total internal refraction will happen. So we need to draw the line. Okay, so this one is a just now triangle. So the light just go in, they hit, then after that they will total internal. Second time, total internal. So that means they happen twice. Total internal refraction for periscope. Okay, state the characteristic you form So first one should be upright. Okay, you see the image must be upright. Another one should be the same size. That's why they can using for the submarine. They can observe in the land what actually they will happen. So from here, the answer upright and also same size. Okay, then we go to the last one. That should be the question 12. They're talking about the object in the pool. So explain why the object appear closer to the actual depth. Okay, you find it. The actual depth is the bottom. When you just see it, you find it just less. That means they just appear above the depth. That means they're near to the surface. Why like this? Okay, the phenomena we're using, there's a refraction. F-R-A-C. Because the light travel from two medium. They will refract away from the normal. So that's why you see the bottom just appear less depth. Okay? So the answer, refraction occur. Light from the object is refracted away from the normal when it just emerge from the water to the air. Okay, now the depth. They give you the real depth is 3 meter. What is the apparent depth? So they give you refractive index 1.33. Remember formula, n equal capital D over small d. So n equal real depth over apparent depth. So 1.33, then the real depth is 3 over the small d. So I get it, apparent depth is 3.99 meter. Okay, the last one, they ask you about the pool is filled with the liquid X. The refractive index is 1.5. Just now it's 1.33, now it's 1.5. The meaning is the liquid is more denser. When the liquid is more denser, how the light to travel? The light travel from the liquid, after that they will bend away, is it? Now they will bend more away. Okay, because the difference is bigger for the density. So now they will find it, the object is appear closer to the surface. More closer to the surface. So from here, the object look closer to the observer. Okay, reason is the light is refracted away from the normal water at the greater angle. Just now it's a normal water, now it's a special liquid. So that means they will bend more away from the normal angle. Okay, so that's why you find it the object is more closer to you. So this one is a reason. When I change about the refractive index, or you say about density of the liquid, then the apparent depth also will be changes. Okay, so hopefully you check your answer and do some correction. If you don't understand, that means you can PM me, ask about the reason. Okay, why the question like this. Okay, so this one is our discussion for the Form 4 KBSN. Sorry, not KSSM. So for the student KBSN, you also can refer this one question because they're almost the same like your syllabus. Okay, just thank you for your watching.